All right, so let's start by taking a look at the circuit here. It's pretty straightforward. It has a source, and then a parallel, and then a series. And so the electricity starts here, splits, rejoins, passes through a resistor, and then returns to the source. So when I'm looking at this resistor strikes me as being easier to deal with than these two, because everything leaving the battery ultimately has to come through these points. Now it's being changed by this, but this resistor is the one I want to start with when I get around to it. That's what I see looking at it. And it's only because I've done a lot of these problems that I can glance at it and say, okay, that's going to be the easy approach. It's going to take time, regardless of how it's set up. You're going to want to start on this outside column. Like, I already told you what R1 is. It's 600 ohms, and R2 is 1800 ohms, and R3 is 900 ohms. Like, I already have all those things, and I asked you to find REQ up here and see 600 over 1800, invert 450, 450 plus 900. Okay, so it's 1350 is the equivalent resistance here. And like I know I've got a 36 volt source, so I can take 36 and divide it by 1350. 0.0266. So that's the current in amps. And see, R3 is easy. I'm going to say that the current is 0.0266. If you're not clear why, that's literally because all of the electricity moving through here has to pass through here. There's no parallel path. If it's coming from here and getting to here, it's got to go through the resistor. So the current is a constant here. Excuse me. And if I multiply these two numbers together, we get the resistance times the current. It's going to give me the voltage, and it's going to give me a number of basically 23.9 or so. Now you'll notice there's a voltage drop here. I use some of the voltage, but not the rest, which means both of these have to be at 12 volts. Because remember, the potential is the same on both sides of a parallel circuit. That a parallel circuit, something that's split like this, has the same voltage in both spots. So if I see that, I can just put the voltage in, because 12 plus 24 equals 36. And now I get numbers. Like I get 12 divided by 600. Okay, that's 0.02. So like 0.02, and the other one is what? 12 divided by 1800 is 0.00666. And we're done. And take a look. When I take the number from this one and add it to the number from this one, together they give me this one, which makes sense. When I add these two together, I get this, which makes sense. When I run Ohm's law over here, I could take 36 and this number together and use them and prove, okay, 1350 ohm. Everything should be pretty straightforward. On the second problem, I'm not going to go through it all entirely with you, because I don't need to. Because if you look, the circuit, because it looks difficult, but it's really just a one big parallel circuit. So like everything's at 64 volts, and as long as you know everything's at 64 volts, everything else is going to come right out nicely.